Hi everybody. Today we're going to do lesson 815, zeros, solutions, roots, x-intercepts. Okay, that sounds like a lot. They're all exactly the same thing though, of quadratic functions. Okay, so first this is really a review of solving quadratic equations and graphically and algebraically. So the first thing we're going to do is we're going to write the different ways that we can solve a quadratic equation. The first way is by factoring. So the GCF or the X, those are the two ways. The second is square roots. So using square roots. The third is completing the square. And the fourth is the quadratic formula. Okay, so that was from a few weeks ago. All right, I'm going to write the quadratic formula, see if you remember it. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Make sure you put the whole, a line under the whole entire top, or numerator as they call it. Okay, so those are four ways to solve a quadratic equation algebraically. All right, so up here, maybe you want to write algebraically. Whoa, that's messy. Okay, so I'm going to give you an example. If we have something that says, oops, example 1. If we have an equation that says x squared, well, the minute I see x squared, I know that it is a quadratic equation. Okay, so minus x plus 7 equals 0. Okay, so it's a trinomial. I'm going to try to solve it by using the x. If you remember, the 7 goes in the top, the last number goes in the top, and the middle number goes in the bottom. We're looking for two numbers that multiply to be 7. Well, 7 is a prime number, so it's 1 times 7 equals 7. But look, 1 plus 7 does not equal negative 8. So if you recall, we want to change the sign of each of these, and that gives you negative 1 times negative 7 equals positive 7. Negative times a negative is a positive, and negative 1 minus negative 7, or plus negative 7, negative 1 plus negative 7 is negative 8. Okay? All right, so what we do is we do double bubble equals 0. It's still an equation, so you have to have an equal sign. X minus 1, x minus 7. Okay, we break that into two little equations. X minus 1 equals 0. So what we're doing is we're setting each factor equal to 0. Now all we have to do is solve these little equations here. So x equals 1. Here we're going to add 7 to both sides to get x alone, and x equals 7. Okay, so those are called solutions. They're called zeros. You could call them the x-intercepts also, and the roots, but we're going to look at that in the next way we're doing this. Okay, so that's our first example. We're going to do that first example again, except for we're going to write that function just a little bit differently. So y equals x squared minus 8x plus 7. All right, now there is no difference. I mean, there is one difference between the first way we did it in red and the second way, and that's just the first way we set it equal to 0 because we were solving it algebraically. We had to write it as an equation equal to 0. Now we're going to graph it, which means when it says y equals, we know we're going to go to our calculator and just put in y equals x squared minus 8x plus 7. Now, I've already done that, so we don't have to waste time putting stuff in the calculator. So you're just going to make a table of values, x, y, and we are going to go from 0 to 8. And the x's, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then on the other, we're going to, on the y's, 0 gives you a 7, 1 gives you, hold on a sec, 1 gives you 0, 2 gives you negative 5, 3 gives you an output of negative 8, input 4 gives you output negative 9, input 5 gives you output of negative 8, 6 gives you an output of negative 5, 7 gives you an output of 0, and 8 gives you an output of 7. Okay, so now what we're going to do, I'm not going to graph this on graph paper because I feel like it's unfair. You don't have the graph paper here. So we're going to make an XY axis as neat as you can. I'm really talking to myself when I say as neat as you can. Okay. X, Y. Now, what we're going to do is we're going to estimate where these points would be, okay? So 0, 7. So 0, 1, 2, 3, 4, 5, 6, 7. There's your first point. You know, I'm going to change it to red. All right, 1, 0. 2, negative 5. So 2, 1, 2, 3, 4, 5. 3, negative 8. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Then the next one's going to be negative 9. And then what you can do is just kind of copy it so it's symmetrical. I am graphing, or yeah, I am sketching these points here, but I did it just because I know it's symmetrical. I could just go up the other side. All right, we're going to make a curve here, which is your parabola. The left side was so neat, the right side's so messy. Okay, now here we're looking for the x-intercepts. The x-intercepts are where it goes, where the graph goes through the x-axis. All right, so I don't want that color. I want this color. Here's one of them, and here's the other. Now, I know when you're graphing, you'd be able to count over to them. So I'm just going to tell you this guy here was x equals 1. All right, and that comes from here. The x-intercept is when y equals 0. And so what would the other one be? Well, look, the x-intercept is when y equals 0. So that's x equals 7. Now with graph paper, we would have just counted over. Okay, so here's the deal. Look at your solutions when we did it algebraically. We had x equals 1 and x equals 7. Look at what we call the roots of this equation, of this parabola here. Okay, those are roots. X equals 1, x equals 7. It is exactly the same thing. One is solved algebraically, one is solved graphically. Okay, we're going to do a couple more of these, but not today because I'm getting to the 10-minute point. So all I want you to do is make sure that you copy this down, take a picture of it, and send it in. All right, copy what I did. The point is that the the algebraic way and the graphic way should give you the same answers. Okay, have a good day, everybody.